break my neck right there, huh? All right. Let's start the first thing off here. So I went and looked at your. One day we're gonna be ready to do that. I went and looked at everyone's topics and kind of lumped them into groups that I think would be complementary to each other. Again, like I mentioned, it is not required that you work with the person in this grouping. This is an individual project. It is an individual presentation. However, working together might make both of your presentations or multiple presentations within groups easier to do, right? Because you can bounce ideas off each other. You can kind of say, you know what, I'd like to cover this topic. I'd like to cover that topic. How can we make these things kind of cohesive so that we get a broader impact? We call that synergy. That the three of your projects together are greater than the individual of each one. For those of you who are doing individual projects, Troy, I'm excited to hear about yours. That was part of my dissertation, but I didn't look into it enough to know kind of that. So I'm really looking forward to hearing about what really happened, especially from someone who was there. And you're also individual with the subsidence of the soils, so you're kind of stuck however you would if you believe you can make it in. So does everyone kind of see and kind of agree that the I guess it would help if y'all could see what I was seeing, right? Problems in this room. Oh, it's not just me. All right, so I guess until this thing comes up, so I have kind of along the rainwater collection. Curtis, Masters, and Williamson. So I have Curtis for rainwater collection, and then Miss Hannah, you had green roofs, and then Williamson is Williamson, and you had natural water infiltration. And so if y'all three get together, and I guess the way I see that is that Anna talks about the rainwater collection, and then your first name? Drew Williamson. Drew's going to talk about the natural water filtration and some of the things that you can use, and then Miss Hannah is going to give you an application of the water filtration from the green roofs. You'll see how that kind of works down, and all three of you cover this broad topic together. Again, they likely to be individual presentations, but they could complement each other. And so then the rest of the class is all doing irrigation. We got Logan Hewitt is going to do irrigation in general. We have Miss Chloe on drip irrigation. Nathan McMeans on, is this thing coming up or not? We have Nathan on pivot irrigation, and then the other Hannah on regular irrigation, right? And so the four of y'all can kind of get together and go, how do we talk about this? And so since you have drip irrigation, you might be the last one to go. And then that ties in with, nutrient management and maybe vertical farming and how that could be something tied in there. We got Cassie and Michaela doing water erosion and NRCS practices. And then we have Misty Jones and Anna Lynn doing some sort of regenerative agriculture, dealing with pasture management of some sort. We got Mackenzie and John. Mackenzie is going to do hypoxia zones, and John has variable rate in application. Those can tie together. We got Peyton and Anderson are going to do some sort of plowing. We got Troy with the coal ash spill, and then Miss Kitty with the subsidence of the Everglades and organic soils in the Everglades. And if this thing ever comes on. Everyone cool with that? Y'all understand kind of... Oh, I had Isaac and Ashton Gunter. Is Ashton here today? Isaac has GIS and water conservation, and then Ashton has water privatization. So maybe that flies in. The next question is, who is brave enough to go first? I knew you were. All right. Okay. Anyone else would like to go on the 2nd? March 2nd. We got Ricky. Who else? Okay. Troy. Can I get one of y'all irrigation? Anna Lynn wants to go, and Hannah. All right, we need a few more. And so since y'all two are going to go irrigation, since the three of y'all are going to do irrigation on the 2nd, y'all should all be kind of talking about what you're going to do. And so I talked with Hannah, and she sets up 3 types of irrigation. Pivot, 3 or 4, it doesn't matter, it's cool. Pivot, drip, and something else, furrow, whatever. And then y'all come behind and kind of work with that. Who else wants to go first? Get it out the way. Mackenzie. John, you want? Okay, Cassie's going to go. Yes, ma'am, March 2nd. And I had you for history of water erosion?
Yes.
Okay. 2, 4, 6, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did they not show up yet? Anyone else for the 2nd? I had Anna Lynn, I got her down. We still got a few people. How many people are like, no, I'm going on the 4th? You better reserve your spot now. On the 4th now, this is the Thursday. This is the 2nd set of presentations. Yeah? Bryn, hold on. Because guess what? Everyone else is getting the 2nd after that. So if we fill up all the 4th, they're screwed. That's one of the perks of coming to class. Hannah, you wanted to go on the 4th? 4th for Anna Curtis. 4th. It's either the Tuesday or the Thursday. Not a hard choice. If you didn't want to go on the 2nd, then you want to go on the 4th. 2nd or the 4th? Which one? All right. Who else? Yes. on the second. Most of this side of the room is chosen. Logan, I'm sorry, Drew. Drew, are you want to go on the second or the fourth, brother?
Do I need to go to the same day as the...
You don't have to. No, you do not.
I'm going to second.
Okay. Looks like most everyone else is going on the fourth then. Hannah, fourth for you. I'm going to post this spreadsheet in there. Logan is going to be on the fourth. Gunter, Michaela's on the fourth. Josh, you're on the fourth. Misty, John, Russell, you're on the fourth. Peyton and Anderson are going to go on the fourth, and I think that's got everyone down. I will try to make sure that I get that. This whole computer thing is about to get on some people's last nerves. Oh, that would have helped, huh? Okay, cool. So I guess it just doesn't show PowerPoint or Excel. Not a problem. Okay, so I looked over everyone's quizzes. There were some errors on my side. Errors on the class side, and some gaps that could probably stand to be filled before we get to the test on Thursday. Now some people had it okay and whatnot, but there were still some that had some gaps, and I'd just like to go over and make sure that we get clarified the errors that I made, and then also that y'all are headed in the right direction moving towards Thursday. So, which of the following soil structures would you expect to have the greatest infiltration? I think everyone did pretty well on this one, right? Which one, Miss Katie? The sandy loam. The sand is going to have a greater infiltration rate. Bigger pore spaces. The columnar structure. The high sodium content. I'll also try and make sure that this becomes available so that you can see them today. Soil's ability to withstand applied stress. Consistence. Which one would have the greatest water holding capacity? The clay loam, the one that has the least amount of sand, right? Because that's the one that's got the greatest infiltration. Infiltration moving through the soil profile. Water holding capacity not moving through the soil profile. And then if the clay loam has the greatest water holding capacity, which one would have the least water holding capacity? The sandy loam. All right. Everyone seemed to do okay with the organic matter content, the soil minerals. That one pretty easy. The soil's high in which clay would have the greatest strength swell capacity? 1 to 1, 2 to 1. How many say 2 to 1? 2 to 1. Non-silicate. We never even talked about that. So if the high strength swell is 2 to 1 and kaolinite is a 1 to 1, it would have the lowest strength swell potential. This one. This one right here is where I made the mistake. I copied wrong, and the question read, as temperature and moisture increase, as we increase our moisture and our temperature, so we're in Florida, And this is the reason why we don't have any organic matter in our soils in Florida. Does organic matter increase or decrease? It decreases, right? So if you put increase, you got it right. If you put decrease, I went back and made sure that you got credit for that. But I need to clarify this as part of my responsibility to you, that I put the wrong answer in with temperature increases and rainfall increases, organic matter decreases. Okay. And then finally, when would you expect to encounter the highest water table? In the winter and the spring. Now let's think about why. Does it rain in the summer? No. So summer's out. That's two of the choices gone. And then finally fall and winter. Well, what happens in the wintertime after it snows and we have that snow melt? That's going to infiltrate into the ground, right? A lot better than our rainfall would. Because it's not running off. It's just going to slow melt and drip through. That's going to increase the water content of the soil. And eventually it will percolate down. We'll catch a little bit of rain. But then what happens in the springtime? All the moisture starts moving across the country, and then we get the rain. And that water has to go somewhere, either in or out. And so that is going to influence our water table. I'm just going to put the, all right, so here, well, everyone got answers correctly. I just think there was a gap between what I was asking. So some of them are the difference between a type or a process or a subtype. I ended up asking on one of these, I asked what was list of 3 types of erosion. And that question should have been listed 3 types of water erosion. So there's some errors on my side where I did not ask the question correctly. But I want us to understand this is a cause and effect. You're lucky today. This is a cause and effect. Oh, you did it? Okay, good. This is not a type of soil degradation. Deforestation is not a type of soil degradation. It is the cause of the type. It allows the type to happen. So, because we overgraze our fields, we have soil degradation. Because we overexploit vegetation, we have soil degradation. Then I asked the 5 types of degradation. So once we have deforestation, which is the cause of the degradation, now we have the type. Was it caused by wind, water? Was it a physical deterioration where we killed the crap out of it? Was it some chemical deterioration? So, cause. And then within each one of these in deforestation, one of these occurs, and that's why we have soil degradation. So, cause, type. And just when I asked that question, people were entering the type when I asked for the cause, and we're entering the cause when I asked for the type. I just wanted to get that clear. You got it correct. It's just not in the correct problem or the correct question. That's all that is. I just wanted to make sure we get some clarification as to how that's looking. And so then next, so here we are, we have a physical deterioration, which is a type of soil degradation. And then there are subtypes. And I probably should have put subtypes in there. I can own that part. Like when I look back at it, I go, you know what, if I had put subtypes, they would have known. Right? But when we have this little indicator right here, PC or W or A, that is a subtype of physical deterioration. I'll make sure that I ask that properly. Next, I had people put the processes for the types of degradation. They got them all correct, just under the wrong question. So this is a process. It is a process of coalescence, which means it's not just a single thing. It took a lot of that coalescing. Those soil particles had to move together. It is a process caused by wind, or maybe water, or whatever. But this is a process. The mechanisms. What happens? Like there's some, when I think of mechanism, I think of a force. So I have a raindrop that hits the soil, causes detachment. Gravity transports that soil with the help of water and wind to the bottom of the slope where it settles. So impact, movement, settling as a process or as a mechanism, some force and motion. And then I asked, what are the three types of erosion? And y'all, we've only been over three. At this point in the quiz, there's only three that we could possibly go over. And some people put detachment, transport, and deposition. Some people put physical and wind and water. So the three types are going to be sheet, rill, and gully. The mechanism, and then kind of the mechanism and the cause is impact of the soil, detachment from the soil, transportation, and deposition. So what happens here is water from up top hits the soil and moves it in a uniform manner. And then finally it deposits. But these are the types of water erosion. I will make sure that I ask that properly, especially as we move forward, because there are different types of erosion. There's water erosion. There's wind erosion. In the next PowerPoint, they have like 5 or 6 other erosions. Like no one can be happy on just one thing with trying to define what these are. And I promise you, when I pulled these from the book, the authors of that book and editors sat through this long process of determining on whether or not it was a mechanism, or a type, or a subtype, what those were. So when I looked at the quizzes and I said, you know, I had some errors in there. I need to make sure that people are getting credit for it. I need to make sure that we're on the right page to what the correct answer was. But then when I looked back at some of the other ones and I went, they had the right answer, just in the wrong place. And maybe it was a misunderstanding between what I was asking. So, does everyone have a better understanding when I say type, or subtype, or mechanism, or process? It will be very specific in the question when I ask it. I try very hard to make sure that I'm asking a very specific question. And remember, we ended with this. This was the last slide that we ended out of that group of notes. This was the gully erosion. So when I had some other people adding some other stuff that wasn't in the notes, we kind of went, we should have stopped right here. These should have been the three things. I will ask, what are the three types of water erosion? Chloe's going nuts back there. Please. Again, I was talking with some other students, but I'm not here to fail you. I want to make sure that you are doing well in this class, and that you're going to continue to do well. So the quizzes were not difficult, and I think everyone did well other than misplacing a few things. But as we move forward, we're going to raise the bar a little bit each time. So I want y'all to start off solid. I'm going to get your feet up underneath you, and then we'll continue on to progress. A couple of other things that I needed to mention. There were only 2 quizzes in the final exam for Module 1. I took out the assignments and the articles. We're going to start doing those in Module 2. We also took out that presentation. So y'all have done everything you're supposed to do up until this point, except take the exam. So some people were freaking out. They're like, I didn't see assignment 1 or 2 posted. What does that do? Not do. I just took that out. I think we could all use a little breathing room. So, also, a couple of things where I saw some students that were back and forth, and it was like, they put it on this one, and then they did the other one, and it was like, you had those backwards. So, soil quality, referring to the function. Is it like, think about it like a car. The quality of the car is basically its function, its form, how well it performs. I used to drive a POS Nissan Sentra, the old school way. It was not quality. Had to get a new car. But soil health is referring to it as a living function, as a living thing. This infinite, non-renewable, dynamic living resource. So, soil quality, referring to the function of it. Is it functional? Soil health, is it sustainable? And I think I think this is just really going to be kind of studying and going over that a little bit more to make sure that you know which one is in which class. This will probably be something that you will see again. You will likely see the quizzes again on the test. But I want you to know the information, be able to carry it forward as we move on. Any questions on that? Anything else that y'all would like to cover as far as the exam goes? Do we need to go over anything else, y'all? Are we okay now?
It is in class this Thursday.
What's that?
It's in class this Thursday.
And it's in class this Thursday, correct. And so I was also talking with some other students. If you had to write it down, there's probably a reason for that. That's probably most of the information I'm going to want you to know, or at least to be aware of. So that's a good direction for studying. All right. I think was there anything else. I will try to get the rubric posted so that way y'all have some guidance as far as your presentations go. 5 to 7 minutes. Again, just want you to get comfortable giving a presentation and getting the flow of that going. I found some more information about this universal soil loss equation, and so there's the one that the original one that we did that we went over on Tuesday. That was the very most basic one. And then as we improved scientifically, someone said, wait a minute, we need to take into account some more other things because we need to get more precise about what this is. So they came up with the revised universal soil loss equation. And then as if that one wasn't enough, they said, we don't like that one either. We have the revised universal soil loss equation 2. So they take it in more account and they start doing it on a daily basis. And so they'll calculate that over the course of the year, and maybe we go from, we're losing 4 tons per year to now maybe we're only losing 2, because it doesn't always rain. So if you don't have any rain, you're not going to lose any soil, at least not to water. Now, because we have more than one type of erosion, they have a wind equation for this as well. So we went over those erosion processes, detachment, transportation, deposition from rainfall. We have some real erosion. Like I said, now we have more types of erosion that are going on. So the impact one being a physical detachment. If you get into rivers and streams and start moving into water quality, you'll be dealing more with channel erosion. We might go over a little bit of that later on in the semester with Manning's roughness coefficient and how you can determine to kind of slow your river down so that you're not wasting away your banks, because that soil has to go somewhere. And then mass waste, landslides, swamps and whatnot. Again, like I said, I'll post these notes, mostly just to say that for the most part, we're concerned with sheet, rill, and gully erosion. So this revised universal soil loss equation is typically just for the sheet and the rill erosion, because those are the ones that we can control, or we can at least fix. Once you get the gully erosion, you're screwed. So it doesn't consider the gully or the stream maker the mass wasting, but it does assume static conditions. So it doesn't really take into account for any changes that might be going on. We went over this last week, the different components of it. You're not going to need to remember the formula because I'm probably going to give it to you. I'll say that the R equals K equals the LS. So just to understand that there are these components to it, we can find these from some table. Someone else has already done the work. All we have to do is Google, pretty much. And if you get into maybe work with the USGS, they have Excel spreadsheets with macros, and you can change that and it spits out a number for you. But just to understand that these are where we get our components.
Are there going to be a few of the USLE problems on the exam?
No, there will not. Because that's a whole, we ended up with the last thing we went over where it stopped was the gully erosion, the big hole in the field. That was it. This will be on the second exam. Yeah. All you need is a pen or two and a brain. It'll be good. So not only did they, I guess in the original USLE, they just took into account rainfall. They didn't really take into account the whole breadth, the whole brevity of precipitation, which would be snow. So when you add a little bit more of that water to this system, it changes it a little bit. And then also freezing and thawing. We've seen how this will change over the course of a year. This is actually somewhere from California, and the map that we use to get this rank, the R value, is called an iso-erodent map. We knew we couldn't do much about the weather, so the primary thing that we want to do is make sure that when we're trying to schedule some grading activity, that we do it when we expect it to be dry, which is going to be in the summer, which makes sense because in the winter and I don't want to work outside in the winter. And then also it rains in the spring, and I'm also not trying to slide my bulldozer as I'm trying to grade this thing. So just some things to think about that if your boss says, hey, go out there and plow this field in the middle of spring, like, wait a minute, might want to hold off there. In the Russell, they start to take into greater consideration about the soil texture and the structure and organic matter. And again, this is something that you can go look for online if you go work with the USDA or NRCS. They'll have that information for you. And so this is kind of why I set up that whole structure and infiltration, those soil physical properties that are going to influence how much our soils erode, that aggregate stability, aggregate pulverization. If we don't have the aggregates, it's going to run off. It's not attached to anything. It's very loose. This also brings into account this nomograph. So for those who have had soils, this is a soil textural triangle. For those who haven't, when we do the hydrometer method, we can figure out our soil textural class by kind of triangulating our sand, silt, clay content. It's very simple to do. Take a line up the percent sand, a line across percent silt or clay, and you can come up with your soil textural class. This nomograph begins to kind of give you some segmentation in between each one of these different textual classes. Again, because we can't just have just one basic number. We got to get that really fine-tuned and get it down to the exact pound of soil that we're losing. So they did a lot of research and they finally came up with this nomograph that takes into account some of the structure, the aggregate stability, organic matter, maybe it's stony. We have that problem here in Tennessee. So it takes some of those things into account. Our K factors are going to be based on our soil texture, right? That erodibility. And so we see that in our high clay content, the value is low. As we move into our medium textured and silt content, as that increases, our erodibility is going to increase because the soil particles, the silt is easily detached. There's not a lot of aggregate stability in our silt soil. This information is explaining some of the things that they take into account with the nomograph. If we increase our bulk density, we increase our compaction, and therefore we decrease our infiltration. And so we would have reduced permeability and greater runoff. And then also that as our pH increases, we will also increase our erosion potential because we would start to get sodium. Remember we talked about the columnar, we had this exchangeable sodium content, and sodium causes a dispersion. So when we have high sodium in our soils, those particles are not adsorbed to each other, and they're dispersed and they're very easily moved. LS, there's not much you can do about the length and the slope, but that the slope, we find that from this table. We find that from a table. Again, not that you need to memorize anything, just be able to look that up. What's important about the LS is it's going to assume that it's uniform, but slopes are very rarely uniform, especially when we start getting into hilly areas. And then as the steepness increases, rather than the length, is going to increase your soil erosion. And you got to think about it. There's not much gravity moving soil when the slope is very level. As we start to increase this, we have a slope that looks like this, our soil is now going to move because there's gravity. And if you get enough water going underneath that soil, you can lose a whole hillside. We went over the C factor, going to be our cover management. And then as we start to get into this, they have separated that out into, you start to get more defined values based upon the different types of cover crops that you use. As we get into the semester, we will start looking at cover crops and we'll develop our cover management practices to decrease our soil erosion. Our support practices are going to again be our plowing and tillage practices and how much residues we're leaving in the field, which is going to slow the movement of water, which is going to slow the movement of the soil. This also takes into account an increased P factor. Remember that we talked about that if there are no erosion control practices, the value is 1. But if we start having some of this as compacted or smooth, that there's no roughness to it, there's nothing slowing that water down. So the revised universal soil loss equation is taking into account some of the other things that they just kind of generalized in the USOL. I want to finish here. I will encourage y'all to go home and study for your test. And when we come back next week after a fresh brain, fresh weekend, we'll start getting into more of the work and effort that we're going to be with the universal soil loss. Thank you so much for your time. If you have any questions, email me.